All right, algebra. Today we are going to solve rational equations. Starting off with the definition so we know where we're going. A rational equation. A rational equation is an equation that contains, dun dun dun, rational expressions. Okay, so example number one, we're just going to dive right in. We have x minus 7 over 7 minus x plus 2 over 3 is equal to 1. So we need to solve this for x, all right? Our first step to solve this for x is to multiply both sides by our LCD. So what's our LCD of a fraction or a rational expression? Or of a set of rational expressions that have 7 in one denominator and 3 in the other, well, the LCD is going to be 21, 7 times 3. So we're going to multiply both sides of this expression by 21. Why? Well, we're going to be thinking back here, way back to, I don't know, when did we do this? Probably chapter 3, where we work to clear the fractions. Anytime we can clear a fraction, we make our lives easier, right? So when we do 21 times x minus 7 over 7, what that's going to do is it's going to cancel out that 7 in the denominator. The 21 in the first expression is going to become 3, right? And we're going to end up with 3 times the numerator, x minus 7. Then we multiply the second rational expression by 21. That's going to cancel out the 3 in the denominator, leaving a 7 in the numerator, and that's going to be 7 times x plus 2. And that's all equal to 1 times 21 is 21. Remember, we multiply both sides by 21 so that we keep our equation balanced. Now, we need to solve for x. Distributive property gives us 3x minus 21 minus 7x minus 14 is equal to 21. Combine your like terms. 3x minus 7x, negative 4x. Negative 21 minus 14 gives me minus 35 is equal to 21. Add 35 to both sides. We have negative 4x is equal to 56. Divide both sides by negative 4, and x is equal to negative 14. And now we're all done with that one. Example number 2. We have 1 over 2x plus 5 over 12 is equal to negative 1 over 3x. What's going to be our LCD between 2x, 12, and 3x? 2x, 12, and 3x? It's going to be 12x. So multiply both sides by 12x so that we can clear our fractions. Okay. So in our first expression here, the x's are going to cancel out. The 2 is going to cancel. The 12 is going to become a 6. So we have, I shouldn't have crossed that x out. I don't want to cross it out because I don't want to lose track of it. Okay, so we're going to have 6x, okay, as our first term now, plus 12x times 5 over 12. The 12 in the denominator is going to cancel with that 12 in the numerator now, leaving me just with x times 5. So we have 6x plus 5x is equal to, over on the right-hand side of the equation, the x's are going to cancel. The 3 is going to go away. The 12 divided by 3 is going to become a 4, and now we just have 4 times negative 1. Okay, 4 times negative 1 is negative 4. Okay, and I shouldn't have left that x there. Okay. So now we have 6 plus 5x is equal to negative 4. Subtract 6 from both sides. 5x is equal to negative 4 minus 6, negative 10. Divide both sides by 5, and x is equal to negative 2. Now you can go back and you can check your answer. I'm not going to take the time to do that right now, but you guys could do that. Okay. Now, as we move into example number 3, notice that we have a rational expression in the denominator, okay, of both of these. So I have on the left side and on the right side of the equal sign. What could be the potential pitfall here is if we end up with any sort of values as we're solving for x that are excluded values. So what would our excluded values be for example number 3? Well, x plus 1 cannot equal 0. and x minus 6 cannot equal 0. So if we subtract 1 from both sides, x cannot be negative 1. And if we add 6 to both sides, x cannot be 6. If we end up with a solution after we work through and solve this for x, if we end up with a solution that is one of our excluded values, that's called an extraneous solution, and it would not be included in our possible solution sets for x. So anytime you see a rational expression in the denominators when you're solving, you're going to want to make sure that you don't include any extraneous solutions in your final answers. Okay? Now, let's work through solving this. We need to multiply both sides of this equation by the LCD. What's the LCD of x plus 1 and x minus 6? Well, it's x plus 1 times x minus 6. So we're going to multiply this side, x plus 1, x minus 6, x plus 1, x minus 6. Okay? On the left-hand side, our x plus 1 is going to cancel, and that's going to leave us with 5 times x minus 6 is equal to, on the right-hand side, x minus 6 is going to cancel. So we're left with negative 2 times x plus 1. Distributive property, 5x minus 30 is equal to negative 2x minus 2. Get your x's on one side and your numerical values on the other. So we're going to add 30 to both sides, and we're going to add 2x to both sides. That gives us 7x is equal to, what did I do? I made a mistake somewhere, guys. What did I do? Anyone figure it out? Ah, ha, ha. What did I do? There it is. Negative 2 plus 30, not positive 2 plus 30. 7x is equal to 28. That's going to end up much easier to deal with because when we divide both sides by 7, x is equal to 4. Now, x is equal to 4 is not negative 1 or 6, so we don't have to worry about those extraneous solutions. Okay? The example above, the example that I just worked through, is a proportion. Because it is a proportion, you can solve this by multiplying the extremes and setting them equal to the product of the means. Remember, that's just cross multiplication when we're solving proportions. This will probably yield a solution quicker than what we just worked through above, but you can only do this with a proportion. So what that means in this case is we could have just gone like this. 5 times x minus 6 is equal to negative 2 times x plus 1. So we get here just a step quicker because we're not multiplying both sides by the LCD. But again, you can only do that when you are solving a proportion. All right, moving on to example number 4. X minus 12 over x minus 10 is equal to 2 over x minus 20 over x squared minus 10x. Okay, first thing we need to do is make sure there's nothing that we have to factor because we're going to have to figure out what the LCD is. And so we always have to do that. We always have to factor before we do that. And the third term right here can definitely be factored. So let me rewrite that. X minus 12 over x minus 10 is equal to 2 over x minus 20 over, factor that x out, and that gives us x minus 10. So now, what is our LCD going to be? Our LCD is going to be x times x minus 10. So we need to multiply both sides of this times x minus 10. Okay, so obviously there's going to be a lot happening here. On the left-hand side of this equation, we're going to cancel out x minus 10. And that's going to give us x times x minus 12. And I'm just going to go ahead and simplify that to x squared minus 12x is equal to 2 over x minus 20, that whole nonsense right here, times x minus 10. So we have to make sure we multiply that x times x minus 10 times both of these terms, okay? So x times x minus 10 times 2 over x. Let's just write that out, and I'm going to do it in a different color so we can see what's happening here. X times x minus 10 over 1 times 2 over x. Our x's are going to cancel out, okay, and we're just going to be left with 2 times x minus 10, okay, and then we have negative 20 over x times x minus 10 times x minus 10 all over 1. Oh, look at that. That all goes away, and we're just left with negative 20. So negative 20. So now x squared minus 12x is equal to 2x minus 20 minus 20. X squared minus 12x is equal to 2x minus 40. We need to get everything over on one side, and hopefully you're recognizing since we have an x squared term and an x, okay, and a numerical value, we're going to end up with a quadratic, okay? So move everything over and set it equal to 0. Thank you, Hallie. Subtract 2x and add 40 to both sides. Subtract 2x and add 40 to both sides. That's going to give us x squared minus 14x plus 40 is equal to 0, okay? Two factors of 40 whose sum is negative 14, negative 10, and negative 4. X minus 10 times x minus 4 is equal to 0. X minus 10 is equal to 0, or x minus 4 is equal to 0. Add 10, add 10, add 4, and x is either 10 or 4, okay? Now, we need to make sure that neither of these are extraneous solutions, okay? What if I put that 10 into this right here? That's going to give me 10 minus 10, all right? That's a no-no, okay? Let's check the 4. 4 minus 10 is fine. What about 4 over here? 4 is fine. What about 4 over here? That's 4 squared, 16 minus 10 times 4 is 40. That's fine, that's not 0, okay? So 10 is an extraneous solution. So therefore, the only solution for this one is x is equal to 4. Last problem. What number must be added to both the numerator and the denominator of 3 over 5 to produce a fraction that is equivalent to 6 over 7? What that means, here we have 3 over 5. We want it equal to 6 over 7, and we want to add a number to both the numerator and the denominator. Okay, so we want to say 3 plus x and 5 plus x is equal to 6 over 7. We need to solve for that x, okay? How are we going to do that? We're going to multiply both sides by the LCD in order to clear our fractions. Our LCD in this case is going to be 7 times 5 plus x. So multiply 7 times 5 plus x. I'm just going to write it over 1 so we can see what's happening. 7 times 5 plus x over 1. Okay, on the left-hand side, 5 plus x is going to go ahead and cancel out. That's going to leave us with 7 times 3 plus x is equal to 7 and 7 over here are going to cancel out. 6 times 5 plus x. Do the distributive property. 21 plus 7x is equal to 30 plus 6x. I'm going to subtract 6x from both sides and subtract 21 from both sides. That's going to leave me x is equal to 9. Okay, x is equal to 9. Obviously, that's not going to be an extraneous solution, all right, because 5 plus 9 is not 0. X is equal to 9.